Hello, scholars. This is Dr. Ball. Before we get started in our statistics class, I would like to teach you a little bit about variables and their structure. So statistics is rather like the TV repairman who comes to fix the TV and cut out the static so that you can get a better video picture. In research, that's what statistics are doing. They're extremely focused and they're cutting out the static so that we can get a better picture of what's going on. Now, for your dissertation, social sciences, educational research, etc., there are going to be three main types of questions that you'll ask. The first is a difference between groups. Is there a difference between groups? Okay. Or it could be over time, like pre-test, post-test. That's within time. So between groups, between men and women, or over time, from pre-test to post-test. These are the easiest types of research questions because they're measuring a difference between some sort of median or average mean score. The next kind of question that's most common in dissertations is a relationship question. Is there a relationship between X and Y? These are usually paired numeric variables. There are exceptions. These are correlational, and they find a line if there is one, and the direction of the line and how strong the relationship is. Okay. The third type is a prediction. Does X or Y predict Z? You could even have, does X, Y, Z predict A? Or you could have simply, does X predict Y? All right. This is some sort of regressional test, and this determines if one or more things can predict the other thing. Okay, so we would literally know, does the temperature predict ice cream sales? So if we took the average hourly temperature and then the number of ice creams sold for each hour, if it predicts the average ice cream cones, the number of ice cream cones sold, we would know for every temperature change how many more or less ice cream cones we'd sell. Now, as you can see from my three types of questions here, there's a few different research designs. Remember, we're discussing quantitative methodology. Okay. And always remember this, experimental designs are the only way you can establish cause and effect, because you have to be able to randomly assign your sample to groups, such as treatment versus control. If you don't have random group assignment, you cannot rule out a confounding variable that might create a difference or a relationship. So the only way to determine cause is with the true experimental design. Okay, but each of these design will use variables of some sort. So a variable is a characteristic, number, or quantity that can be measured or counted. It could also be called a data item. It could be like age, sex, business income, country of birth, capital expenditure, eye color, all of those things. It's called a variable because the value can change in units, it can change in a population, and it can change just over time. All right. A great example is income. It can change between data units, that's participants. All right. And if you think about it, you can study individual level people, individuals, what's your yearly income, or you can study groups as one group is a participant. So maybe I am interested in knowing the average sales for all the grocery stores in the state of Ohio. Each grocery store, which is a group of people, but is one participant. So you can have group level data or individual level data. So the few main types of variables, layered statistics does a wonderful job explaining. If you want to do a quantitative dissertation, I strongly urge you to get a membership with layered statistics, because if you have a professor, a chair who's in absentia or isn't great with statistics, layered statistics teaches you everything, shows you how to do it, how to interpret it, and even how to write it in APA. Okay. Variables are the data that we're going to use to test, and we have basically two kinds. We have numeric variables or categorical grouping variables, nominal, they're named. So grouping variables, nominal, are usually independent variables. They're called independent because they're what influences the possible change, like treatment or control, male versus female, right? So these are typically categorical variables, but you need at least two categories for it to be categorical. So if you only have one group, you don't have a grouping variable, okay? So for example, gender is my independent variable with two categories of male versus female. If I were to ask if there is a difference in height between genders, male versus female, my independent variable is gender because this is the influencer. This is also a between groups categorical variable because I'm asking if there's a difference between these two groups. I could have three groups. I could have four groups. I could have more, right? But my question is comparing the differences between these two separate and distinct groups. One person cannot be a member of both groups. There is also within groups variable, independent variable. These are time points. The idea of time is separate from the score because the testing conditions have changed. An example of time points is pre-test and post-test. What's changed? Usually there's some sort of intervention or learning going on in between. All right. But there's more than one testing circumstance. And you can have more than two categories. You can have more than just pre-test or post-test. You could have monthly scores. You could have, is there a difference between spring, summer, and fall? And the number of asthma attacks for preschoolers, right? My independent variable here is time, a within groups factor, because I don't have boys versus girls. I have one group, preschoolers from Ohio. But what's separating is spring, summer, and fall. Okay. Those are my three categories. Now, dependent variables are typically a numeric variable. There's usually some sort of score. So for my between groups example, the score here was height. Is there a difference between genders, male versus female, in height? Height is the dependent variable. For my within groups example, is there a difference in the number of asthma attacks for preschoolers between spring, summer, and fall? My independent variable is time, spring, summer, and fall. My dependent variable is the number of asthma attacks for spring, and then for summer, and then for fall, okay? But it's the number of asthma attacks. Now, to get more complicated, each statistical design has its own types of variables. A correlational design, you know, when I told you, usually uses paired variables that are numeric. We just call them variables. Regression designs are prediction. That's like, does the average hourly temperature predict the number of ice cream cones sold? So we have a prediction variable. You can have more than one of those, and an outcome variable. Easy to remember, right? All right, and numerical variables can differ in types. Our main variables are continuous, ordinal, dichotomous, and multinomial. Continuous variables include interval and ratio measurements. Interval variables are measured along a line or a continuum. These are numbers that can literally have any value between the lowest and highest number. An example would be temperature, like 98.6 or 30.4. However, notice that a zero temperature does not mean that there's no temperature. So zero doesn't have that absolute value of none. Okay. Now, the next kind of variable we have is ordinal. They're also called ranked data. An example of ranked data is Likert scales. On a scale of 1 to 5, with 1 being completely disagree and 5 being totally agree. Ranked data could also include letter grades like A, B, C, D, F, or less than proficient, proficient, above proficient, uh, excels. Okay, they're ranked, and the order matters. Okay, we can have dichotomous variables, which are nominal grouping variables. That's with only 2 categories. There's no intrinsic value to these. It's like saying, you got any pets? Yep. Is it a cat or a dog? Multi-nominal is like a dichotomous variable, but it has more than 2 categories. Do you have a pet? Is it a cat, dog, bird, or lizard? Okay. And here's a flow chart of the variables from the Australian Bureau of Statistics, right? We've got numeric and categorical. And remember, the categories for ordinal, that rank matters. The order it comes in matters. And here we go. Now, I'd like to explain to you why variable structure is so extremely important. So, is there a statistically significant difference between genders, male and female, in height? It's between 2 groups. So, my test choice requires 1 independent variable, genders, with 2 categories, right? And it's between groups. And it requires 1 dependent variable that is continuous. It's height. Okay. Here's what my data file would look like. And if I was asked to describe my file, I'd say I'd use an Excel document. It'll have 2 columns. I'll use the numbers off to the side for the participant number, and 1 column will be gender with 1 or 2 for male or female, or F or M for male or female, and height with the height in inches. Now, what if I wanted to test the asthma attacks in kids from spring, summer, and fall? Is there a statistically significant difference over time, spring, summer, and fall, in the number of asthma attacks for preschoolers in Northeast Ohio? My independent variable is time. A within groups categorical variable, 3 categories, right? By the way, that's a repeated measures ANOVA. The categories are spring, summer, and fall, and my dependent variable is the number of asthma attack. This is on a continuum where 0 means no asthma attacks. And this is what my data file would look like. Okay. Big difference from this data file, right? So what your data file looks like matters. For this reason, you must understand completely your variable structure. Appropriate test selection is necessary, and you need to be able to explain it to your professors so they can check your work. Okay, so I also created this a variable structure document. You need to be able to answer these in your dissertation. So I show the statistical test, the name of the variable, whatever I'm going to call it, because you can pick what you want. Participation is very common for an independent variable. That is the independent variable type. And then I define it conceptually, operationally, and measurement, and then what instrument is being used to collect that information. My independent variable is participation, which represents whether or not they participated in the intervention. Did they have the bullying intervention or not? It is a categorical variable with two groups, treatment or control, and I'm getting it from archival data. Now, this one also for the independent t-test, which I say is two-tailed here, it's the number of students who bullied, and this is the dependent variable. And conceptually, I'm talking about students who were found guilty of bullying, and it's the summed total score per report per grade in the school. Okay. And I'm getting that also from archival data. So conceptual answers the question, what does it mean? Operational, how is it measured? And measurement level definition is very detailed. Exactly how is it being measured? And that's a big deal. Because you're going to also have to be able to describe what your data file is going to look like in your dissertation. So in this case, I would say, well, besides the numbers for the participants, which are off to the side here, it'll have two columns. One will be the participant's school number. I have 1 and 2 here. In my study, I actually had 8. And then the number of students who bullied per report, summed total, right? Summed total score of the number of students who bullied per report. Don't forget your test selection needs to include the test type, whether it's parametric or not, which you'll talk about later. If you're testing one direction, looking both ways, increase and decrease. And then there'll be assumptions and things like that. Okay, so as far as your research questions go, quantitative research questions are very specific because the hypotheses are very specific and they do not answer how or why. The underlying question to every research question in quantitative studies for your dissertation is basically, do we reject the null hypothesis? And this is a yes/no question. Okay? Okay. Well, I hope that explains everything. Reach out to me if you have any questions.